Okay, so far we've learned about functions, we've learned about their domains and their ranges, we learned about various ways of combining functions. Some of the operations that we have learned are addition, subtraction, multiplication, division, defined accordingly here. For division, just be careful that the denominator should not be zero. These are all the ways of combining functions, and why we care about them is because we can build newer functions by combining already known functions. This week, we are going to learn a new way of combining two functions. The motivation is we want to model an operation that feeds into each other. For example, when you get ready, you put on socks and then you put on shoes, right? Not the other way around. So there's a particular order in which you do things, meaning you perform an operation and then the output of that operation feeds into the next operation as input. And this process is called composition of function. Say f of x and g of x are to be composed, then the input goes into the function f, the output that comes out of f goes into g as the input, and then we get the final output. This is written as g f of x, g f of x, and we read this as g of f of x. Notation. Similarly, if you have f gx, we perform g first, so inside out, followed by f. It's g of f, then we perform f first and then g. Sometimes f of g of x is also written as fog of x, and g of f of x is also written as g of f of x. Caution, f of g of x is not equal to product. Example, if I have fx is 3x minus 4 and gx is x squared plus 6, f of g of x would mean, let's see what g does. G takes x and transforms it into x squared plus 6, so that now I have f of x squared plus 6. And we've seen this before. When you evaluate functions, you just replace whatever the argument is with x. So I replace x with this new variable to get this term. In the diagram, that's what it's going to look like. And the other way around, g of f of x, we would feed x into f, which gives me 3x minus 4, and we feed 3x minus 4 into g. So again, they are not necessarily going to be the same. Another example here, so f of g of x, g of x is x squared minus 1. So f of x squared minus 1 is going to be 5 times x squared minus 1 plus 6. G of x is g f of x. Replacing f of x as 5x plus 6, g of this becomes 5x plus 6 whole squared minus 1. Okay, that's the end of this section. We're going to talk about another special kind of function in the